Hello everyone, I'm Wang Pulin, a Huawei instructor. Previously, we learned about troubleshooting STA connection issues. Starting from this lesson, we'll learn about troubleshooting AP air interface signal issues. There are generally two main issues with AP air signals. One is no signal, and the other is weak signal. In these cases, if you are on-site troubleshooting, pay attention to the condition of the network cables. If you enter a building where all APs are installed by you, like in a university dorm, it might just be a straightforward situation along a corridor, but cases with no signal are rare. Usually, it's hard to detect whether there is a signal or not, since all are broadcasting the same SSID. So the issue is standing here when you receive a number of signals. The signal's AP might not be in the room. You need to determine whether it's a weak signal or no signal. First, ensure that inside your room, after you come in, the AP you're connected to is actually in this room. You need to confirm this step. After connecting to the Wi-Fi, open a scanning software. Use the scanning software to confirm whether there's an issue. Let's continue to look at what the troubleshooting approach is when there is no signal. First, check whether the VAP is created and its status is normal. Normally, configuring VAP is essential. That is, only when the SSID is broadcast can we say the setup is almost complete. Second, check if the SSID is hidden. This is used sometimes, but rarely, like in hospitals. They might have a specific SSID for patients, previously used more frequently by patients. For instance, they might have several PAD devices, possibly used to view images, CAD drawings, etc. Nowadays, PADs have many functions, possibly integrated with certain systems, but they might not want these pads to connect to the patient-used SSID, right? They don't want others to interfere with their video, so they might use a hidden feature to conceal it and have it pre-connected on the PAD, for instance. If there are about 30 to 50 PADs, all are set up accordingly, then the subsequent PADs will automatically search for the hidden SSID and connect to it. So it's important to note here whether there is a hidden SSID, moving forward to the SSID template, right? Check if the configuration is normal. This area is easy to configure. Then there's sending beacon frames. How to check. Use packet capturing software to see. Everyone can understand this. How to. Capture packets in a wireless scenario, what chipset software to use, and what kind of packet capturing tools are required. We talked about beacon frames before. The function of beacon frames is to display the range that the AP can cover. That is, the locations where the beacon frames can reach. So we need to verify if the beacon frames are functioning normally, and also check for air interface interference. The fifth issue is whether the AP's transmission power is too low. The transmission power of an AP depends on the scenario. Typically, 100 milliwatts indoors, 500 milliwatts outdoors, but recently, some products are even reaching 500 milliwatts indoors to showcase their manufacturer's APs with strong signals. Thus, they increase the power. Now, most manufacturers follow this trend, meaning I increase the power a bit to give the impression that my AP's signal is strong. This aligns with basic industry standards, but this trend is becoming increasingly common, all oriented towards results. Next is matching terminal capabilities with the AP, like whether the terminal's network card supports 2.4G or 5G, in which case you definitely can't. Another issue is country codes or AP frequency bands. These are some common signal issues, how to pinpoint them. Moving on to commonly used commands. When we check the VAP status, first, check the status of the AP. Here's something everyone should pay attention to. Configuring WLAN involves 3 steps, right? The first step is configuring the wired environment, which is what everyone calls the basic configuration. The second step involves configuring the AP, that's the STA. When we go to check the AP's configuration, you can take a look, use display VAP, then add the AP's ID to the query. This will show what your SSID is, what its MAC address looks like. This is the status of a VAP. Under normal circumstances, if you've configured correctly, the status of the VAP should not have any anomalies. But there's an issue, which is quite common. When you check Display VAP All, you might find the status field is off. It's important to note here to check whether the RF switch is on, or if the VAP is disabled. Under normal circumstances, the status should be in a normal state, not off. It should be on. This is something to be mindful of when using display VAP all. Then check for hidden SSIDs. You can use display SSID profile named default to look into it. This is a common issue. Now let's look at some RF. Configuration commands, as we mentioned earlier, when the number of connected users reaches a certain limit, the system will automatically hide its RF signal, for instance. If the AP threshold is set to 50, and it already has 50 users connected, it will hide, automatically concealing its SSID. This way, users won't attempt to connect to the AP anymore. They'll connect to other APs instead, thus ensuring the stability of that AP's network. This is found under the RRM template in our radio RF template, and whether hide SSID is enabled. Moving on to some specific configurations, this is the file name for VAP, then apply it under the SSID. Our specific SSID name is what? Next is to check what kind of beacon frames our AP sends out. The beacon frames emitted by the AP. It's best to use packet capturing to inspect, because these commands are diagnostic commands. These diagnostic commands might not always be applicable, so pay attention. Diagnostic commands should be used cautiously. On virtual machines, they may not work. Or even on real machines, they might not be effective. So it's essential to check which commands can be used. It's best if you can capture packets to see exactly what the beacon frames look like if you attempt to capture air interface packets. And you can't see the beacon frames, for instance. The AP's MAC address beacon frames are invisible. This indicates a problem. If you notice a significant amount of transmitted beacon frames and a large discrepancy between the number lost and transmitted, that likely indicates an issue, such as significant losses which could be due to air interface issues, like substantial device interference. With the same information, this could lead to a high number of lost beacon frames and thus prevent effective coverage. So we need to focus on beacon frames within the signal range, how to troubleshoot air interface interference. You can use display AP radio environment to see the current co-channel interference rate. As we mentioned before, it's necessary to check the channel and perform some simple optimizations. In doing this work, we need some software to support, like the scanning software we mentioned earlier, network stumbler, Wi-Fi analyzers, etc. Keep in mind, some software is open source, some is not open source. If you are willing to pay, then download the licensed software to use. If not willing to pay, look for some open source software. Some software does not charge. This is what we mean when we say how to troubleshoot air interface interference. Next are other instruments. Actually, as we've mentioned before, in a 2.4 gigahertz band, the 2.4 gigahertz frequency is part of ISM, right? It's open for industrial, scientific, and medical use, meaning many devices operate at 2.4 gigahertz, like cordless phones, which are now rare, almost obsolete, negligible. The main ones are microwaves, wireless cameras, Bluetooth, infrared, sensors, and some medical devices, which are important to consider. Medical devices might use a bit of 4G and 5G frequencies because we're talking about medical applications, right? So when you're in a hospital, you need to be particularly careful about how to resolve interference from non-WLAN devices. You should avoid deploying APs in such areas because their power might be much higher than yours, and you can't compete. So be very cautious during deployment. You simply won't be able to counteract it. So when deploying, be particularly mindful publicly, as everyday devices at home or in life can also cause some interference to WLAN networks. This is an issue we often overlook. The last thing is to check the AP's transmission power, which can be adjusted automatically or manually tuned for manual tuning. First, you need to turn off the auto-tuning feature, then make adjustments, turn off calibrate, then modify the EIRP, which is to adjust the transmission power. This method reduces the coverage area. Why reduce the coverage area? Actually, it's related to the placement of devices. Some project installation engineers might say that A certain position is not ideal for installation, so they move it a bit, and if another spot isn't good either, they move it a little more, resulting in two APs being too close to each other. What happens when they are too close? There will be overlapping areas, like reaching 30% overlap, which can cause mutual interference, right? So it's important to avoid excessive overlap. Usually, an overlap of 15% to 25% is recommended. Therefore, reducing power can help to ensure the network maintains a reasonable coverage. State. This is about AP power. We can check what the AP's transmission power is like. The maximum power is 32, and here is the current power, CE and MME, current and maximum. This is how we check when there's no signal. The above covers the issues when there is no signal. Next lesson, we will look at what causes weak signals in terminals. Thank you, everyone. Goodbye.